ready to dive into this. Problem 1. Instructions for a craft project say that the length of a piece of red ribbon should be 7 inches less than the length of a piece of blue ribbon. How long is the red ribbon if the length of the blue ribbon is 10 inches? So we know the red ribbon is 7 inches less. So if the blue ribbon's 10 and we take 7 less, then a red ribbon should be 3 inches. If the blue ribbon is 27 and the red ribbon is 7 inches less, then we should be able to do 27 minus 7 and get our red ribbon is 20 inches. I could use my units there. What if the blue ribbon is X inches? So again, here we don't know the exact number, but we know the red ribbon is 7 inches left, so X minus 7. And I can't come up with a single number here because in order to do that, I'd have to know the length of X. So I have to just leave it as an expression, X minus 7. Now it says, how long is the blue ribbon if the red ribbon is 12 inches? Well, the red ribbon is equal to the length of the blue ribbon minus 7. So 12, the length of the red ribbon, must be equal to X minus 7. And then to figure out how long the blue ribbon is, I want to get X all by itself. Now this one, we haven't looked at a lot of equations where we're subtracting a number from X. We've just looked at ones where we're adding a number to X. But I'm still thinking the same way. I want to get X all by itself. So I have to figure out how to get rid of a minus 7. I can't subtract 7 because I would have minus 7 minus 7. I would have minus 14. That won't help me get X all by itself. I have to think, how do I get rid of a minus 7? And the answer is to add 7. But again, whatever I do to one side of the equal sign, I have to do to the other side. So now I have minus 7 plus 7. That equals 0. That's all good. That leaves me with one X on the right. And on the left, 12 plus 7 is 19. And then I want to check that. If the blue ribbon is 19 and the red ribbon is 7 inches less, 19 minus 7 would be 12. And that's what I have for the length of the red ribbon. So this checks. Okay. Moving right along. Tyler has 3 times as many books as Mai. So however many books Mai has, Tyler has 3 times that number. So how many books does Mai have if Tyler has 15 books? Now you have to be careful. You might be inclined to just say, okay, I'm going to do 3 times 15. But this isn't saying Mai has 15. It's saying Tyler has 15. So if he has 3 times as many as Mai, 15 has to be equal to 3 times the number Mai has. So we need to actually divide 15 by 3 to get the number of books Mai has. So the answer is 5. If Tyler has 21 books, how many does Mai have? So again, 21 is 3 times the number Mai has. So to figure out how many Mai has, I have to divide 21 by 3. So Mai would have 7. And then I can check that. If Mai has 7 and Tyler has 3 times as many, then he has 21. Now I'm saying, what if Tyler has X books? How many does Mai have? Well, in each of these situations, we just divided the number Tyler had by 3. So this is no different. Even though I don't know what that actual number is, I know I've got to divide it by 3. So I could represent it this way, but probably a little more comfortable thinking, well, X divided by 3 is 1/3 X. So Tyler has 1/3 the number of, Mai has 1/3 the number of books Tyler has. So if Tyler has X books, Mai has 1/3 that number, or 1/3 X. So now we're going to go on to the second part of this. Tyler has 18 books. How many books does Mai have? So we know the number of books Tyler has is equal to 1/3. No, I've got this wrong. The number of books. Yeah, Tyler has 3 times as many books as Mai. So 18. I don't know. I wrote this differently. If this was me, I'd say 18 is equal to 3 times x. But I'm using our equation here. We know that 1/3, the number of books Tyler has, 1/3 x, which in this case is going to be 18, is equal to the number of books Mai has. And 1/3 times 18 is 6. But again, I'd be probably more inclined to use this. Tyler has 3 times the number of books Mai has. I'd solve this by dividing both sides by 3. And I would still get x equals 6. All right, moving right along. Problem 3. The bottle holds 24 ounces of water. It has x ounces of water in it. What does 24 minus x represent in this situation? So 24 is the total volume of the bottle, how many ounces of water it could hold. X is how many ounces of water are in it. So what would 24 minus x represent in this situation? Well, it's going to represent the amount minus the amount that's left is going to represent the amount of water that has been used. So it's going to represent the amount of water that has been used, or it could be that it's missing, however you want to phrase it. We write a question about the situation that has 24 minus x as an answer. So 24 minus x represents the amount of water that has been used. I just want to write a question about a situation about someone using water. So I could say, how much water did, let's call this person Megan, drink from a 24-ounce bottle if there are X ounces left. And you could have come up with a completely different situation, but it needed to be a situation where you're really finding out how much water was removed from the bottle from one reason or another. Okay, problem 4. Write an equation represented by this tape diagram that uses each of the following operations: addition, subtraction, multiplication, and division. This is easy peasy. So I've got a tape diagram showing me that the total value of the tape is 27, and it's been divided into 3 parts that each has a value of 9. So multiplication is the easiest one. I can see I've got 3 groups of 9 that have a value of 27. So 3 times 9 equals 27. There's our multiplication. And then I could just do the inverse of that for division. If I take 27 and divide it into 3 equal parts, each part has a value of 9. So I could say 27 divided by 3 equals 9. That's my division. I could have also said 27 divided into groups of 9 equals 3. So there's our division problem. Addition, I can see if I add 3 groups of 9, I get 27. So 9 plus 9 plus 9 equals 27. That's my addition. And then I just need to come up with the subtraction. So I could think, if I have 27 and I take away 9, I'm left with 9 plus 9. So 27 minus 9 equals 18. There's my subtraction. So, not too tricky, I didn't think. Okay, next page. Select all the equations that describe each situation and then find the solution. Okay, Hans' house is 450 meters from school. Lynn's house is 135 meters closer to school. So you got to read this carefully. It's not saying Lynn's house is 135 meters from school. It's 135 meters closer to school than Hans' house. So immediately, I think, if I take Hans' house and subtract the distance that Lynn's house is closer to the school, I will get the distance of Lynn's house from the school. And in these particular expressions, we're using z to represent the distance from Lynn's house to the school. So immediately I'm thinking, all right, well, 450, Hans' distance, minus 135, how much closer Lynn's is going to equal the distance Lynn's house is from school. And I see that right there. No, wait. This one, I'm sorry. Don't pay any attention to this. Pretend I didn't do that. Okay. So 450 minus 135 is equal to z, and it's the same as that equation. It's just they're on opposite sides of the equal sign. Okay. Let's look at some of the other expressions here. Is the distance, so remember z represents the distance Lynn's house is from the school. Is his house equal to 450 plus 135? No, that's kind of the opposite of what we just said. We knew would represent that. It's 450 minus 135, so that one cannot be in the running. Here we have z minus 135 equals 450. So if I take the distance Lynn's house is from school and subtract 135, will that equal the distance that Hans' house is from school? No, it would be just the opposite. If I take the distance Lynn's house is and add 135, then I get Hans' distance. So this is wrong, and this would actually represent that situation. The distance Lynn's house is plus the 135 difference equals the distance Hans' house is. So, and then I want to solve this, and this is pretty straightforward. 450 minus 135. I'm going to do some borrowing. 10 minus 5 is 5. 4 minus 3 is 1. 4 minus 1 is 3. So, Lynn's house is 135 meters from school. Okay. Now we move on to the next one. Tyler. Tyler's playlist has 36 songs. Noah's playlist has 1/4 as many songs. So Noah's playlist is 1/4 the number of songs in Tyler's playlist. How many songs are in Noah's playlist? In these, we can see the variable that's being used is W. So W represents how many songs are in Noah's playlist. And so we said if Tyler has 36, Noah's has 1/4 as many. The number Noah has is going to be equal to 1/4 times 36. We could also think if Noah's playlist has 1/4 as many as Tyler's, then 4 times Noah's playlist is going to be equal to Tyler's playlist. So we could also think 4 times the number in Noah's playlist is going to be equal to the number in Tyler's playlist. So let's look at our expressions here. W is equal to 1/4 times 36. Even though this doesn't look like this, we want to recognize that W divided by 4 is the same thing as 1/4 times W, right? Because any number divided by 4 is going to be 1/4 of that number. So even though it doesn't look exactly like this, this is equivalent to this. So that is a solution. 4 times the number of Noahs equals 36. That's that one. W is equal to 36 divided by 4. Well, 36 divided by 4 is similar to, let's see, the number of songs in Tyler's playlist divided by 4. That would be 1/4 of 36. So that is actually also a solution. And lastly, W equals 4 times 36. Now, the number of songs Noah has is 1/4 of 36, not 4 times 36. So that is not a solution. Then we need to solve this. So 4 times W is equal to 36. We want to know what 1W is. We can divide both sides by 4. And we get W is equal to 9. And if we go ahead, this is not correct. Forget that one. It wasn't 1/4 of W, it was 1/4 of 36. My bad, sorry. If you substitute in these other two equations, it does check. Sorry if I mess people up on this one. Sometimes it happens, right? Okay, problem 6. You had $50. You spent 10% of the money on clothes, 20% on games, and the rest on books. How much money was spent on books? All right, so first of all of your money is 100%. So if you know how much was spent on clothes and how much on games and the rest was on books, you can figure out the percent that was spent on books. So if you do 100% minus the 10% on clothes minus 20% on games, 100 minus 10 is 90, minus 20 is 70. So that means you spent 70% on books. So you want to know how much money was spent on books? Well, it's going to be 70% of $50. So I need to figure out what 70% of $50. Well, this is one where I could start by figuring out what's 10% of 50. So 10% of $50 would be 1/10. So it's going to be $5. $5. And then, so 70% is going to be equal to 7 times 10%. So it's going to be equal to 7 times $5, which is going to be equal to $35. So you spent $35. Other ways you could have figured this out. One of the things, I don't know if you remember me talking about this, was that you can actually, when you're finding 1% of a number, you can actually flip the two and you get the same answer. So instead of doing 70% of 50, that would be also equal to 50% of 70. And 50% is half, and half of 70 is 35. So you can also do it that way. Sometimes when you flip them, you end up with a problem that's easier to do mentally, which is the case here. So, all right. Problem 7. A trash bin has a capacity of 50 gallons. What percentage of its capacity is each of the following? Show your reasoning. So, this is the total capacity of our trash bin, and we want to know what percentage of its capacity is each of the following. So, here you've got 5 out of 50. Here you've got 30 out of 50. Here you've got 45 out of the 50 gallons, and here you got 100 out of the 50 gallons. So I want to just convert all these ratios or fractions into percentages, which is pretty easy because they each have a denominator of 50. I can convert them into fractions with a denominator of 100 simply by multiplying the top and bottom by 2. So here, when I do that, I get 10 hundredths, so this is 10%. Here, when I do that, I get 60 hundredths, so that's 60%. Here, for part C, I get 90 over 100, so that's 90%. And lastly, when I do that on problem B, I get 200 over 100, so that's 200%. Okay. All right, that's it.